Folks, so today's revision topic is Pythagoras' theorem. So if we have a little look at this first slide and I explain it to you, we're going to be looking at finding missing sides on right angle triangles. The key words that you need to know are hypotenuse, which is always the longest side on a right angle triangle. It's the one opposite the right angle. You need to be able to square and you need to be able to square root. If you want a longer video, you can go to Maths Watch clip 150A, B and C, and then the 3D Pythagoras is clip 217. So let's just have a little warm up, okay? So our little get to work. Squaring, so we've got 5 squared, 9 squared, square root of 16 and the square root of 121. So if you have a little go at that, I'll give you a minute and then I will show you the answers. Right, so basically we've got 5 squared, so that's 5 times 5 is 25. 9 squared, 9 times 9 is 81. The square root of 16 is what did we square to get 16, so that is 4, because 4 times 4 or 4 squared is 16. Square root of 121, what did we square to get 121? Well, we squared 11, so the answer to that is 11. Okay. There we go. Right, so if we have a look at this memory, we've already done Pythagoras' theorem, so this is a revision video. So we need to remember that the two small sides are A and B. It doesn't matter which small side you call A or B. And the long side is C. So we square the short side and add the next short side squared to it, and then we get the long side squared. So it's A squared plus B squared equals C squared. So let's go and have a little example and work through a few. So finding any side. So there's my theorem again. So you've got to learn the formula. You've got to be able to substitute the values you are given into the formula. And then you need to solve it for the unknown thing that you want. So let's have a look. Algebraic method. Here's a nice triangle. We've got one side that is 15, one side that is 7. We know those are both the short sides. They meet at the square root and we're looking for the long side, the hypotenuse. So let's have a little look. So x squared is going to be the two short sides squared added together. So we've got 15 squared plus 7 squared. We need to then square root it because we don't actually want x squared. We want to know what x is. So we need to square root it and we will get 16.55 meters. Okay, you can pause the video at this point and check, make sure you can do that on your calculator. Okay, right, so second one of our methods is, this is where we've got another triangle. This time we've got 25 meters and 7 meters and we've got another x missing, we've got a side missing, but what the side that's missing this time, look, is a short side. It's attached to the right angle. It meets the other short side at the right angle. So this time we need to rearrange. So we want the long side squared, take away the short side squared. So we've rearranged it. We need to square root it because we don't want x squared, we want x. And we get 24 meters. Okay. Right, quick method. We're close to the exams now, so we can use some of the quick methods. If we are looking for a long side, so that's the hypotenuse, the long side, we can do square it, add it, then square root it. And if we're looking for the short side, or a short side, we can square it, subtract it, square root it. So this is a quick way of remembering what order you do things in. So let's have a little example of that. So example 1, we've got two short sides, look, they meet at the right angle. And we're looking for the hypotenuse, the long side. So if you remember, we're going to square it, so 4 squared, square it, 3 squared, add them together, so that's 4 squared plus 3 squared gives me 25, and then we square root it. So x is 5. If we have a little look at the next one, example number 2, we've got square it, But look, we are looking for a short side, so this time we subtract it and then we square root it. Okay, so that's 2 examples of using the quick method: the square it, add it, square root it, look for the hypotenuse alongside, and the square it, subtract it, square root it for looking for a short side. Right, now they don't always come as nice little neat triangles. Sometimes they're wordy, sometimes they're in an unusual setting. So let's have a look at how we'd start thinking about problem solving. So first thing to do is either draw yourself a diagram, including the right angle triangle, if you haven't been given a diagram. So turn your words into a right angle triangle. Identify which side is the long side, the hypotenuse, and then use Pythagoras in the normal manner that we've been doing it. So let's have a look at some examples. So we've got a rectangle here. We need to find the diagonal. So let's draw the diagonal in. Okay, called it D for diagonal. We can see where our right angle is. It's in the corners. It's a rectangle, so that the right angles are in the corners. So we've got 2 short sides there, and the diagonal is the long side. So let's square the 2 short sides and add them together. Then let's square root that, and we have the answer. Okay, 1 decimal place is fine unless they've told you otherwise. Right, another problem next. Let's have a look at this. So this time it's a very wordy question. Right, okay, so let's have a look. We've got a boat sails due east from a harbour H to a marker buoy B, 15 miles away. At B, the boat turns due south and sails 6.4 miles to a lighthouse L. It then returns to the harbour. Make a sketch of the journey. What's the total distance travelled by the boat? Now make sure that you really take note of that. What's the total distance travelled by the boat? It's all of the distances added up, so make sure you do actually answer this question. So there's my sketch. It doesn't have to be as elaborate as that. You can literally just put H, B and L on each of the vertices, the corners of the triangle. And as you can see, the right angle is at the buoy B, so our short sides are the 15 and the 6.4. So we're looking for a long side. So let's do the long side. So square 15 and add it to 6.4 squared. Square root it and we get the distance LH. So the lighthouse back to the harbour is 16.3 miles away. Now that's only part of the question, isn't it? They want to know the total distance the boat travelled. So we need to add the 15 and the 6.4 to our 16.3. Okay, so I've now answered that question. Okay, be really careful not to miss the last little bit out and do all the hard work. The Pythagoras is the hard work. Just have to do a bit of adding at the end. Right, another wordy question. So a 12-foot ladder rests against the side of a house. The top of the ladder is 9.5 feet from the floor. How far is the base of the ladder from the house? Now the first thing you need to notice is there's unusual units in there. They could put any unit in the exam. It could be kilometres, miles, metres, centimetres, inches, feet. So don't be floored by the fact that you've got an unusual measurement in there. Okay, so let's do a drawing. Again, it doesn't have to be as elaborate as mine. Okay, so we've got the house, we've got the distance from the floor to where the ladder touches the side of the house, and we've got the ladder. And we want to know the distance from the base of the ladder to the house. So we are going to, hopefully you can work out the ladder's the long length, the right angle is between the floor and the house, so we're looking for a short side, so we're doing the taking away. So we've got 12 squared, take away 9.5 squared, square root it, and we get the distance from the base of the house to the base of the ladder as 7.3 feet. Okay, right, so what we need to do now is just have a little look at the last skill, which is Pythagoras in 3D. Because it's in 3, you're going to do Pythagoras twice, so always remember you're going to do Pythagoras twice. So there's my box. It's a bit like a shoebox, and they're asking me to find BG. So if I put BG in, it's kind of in the space, a diagonal in the space inside the box. Now I've said to you we're going to have to do Pythagoras twice, so let's have a little look at how we actually do that. We need to find a triangle first. We always need two sides, and at the moment we've only got one side for that BG, which is the 3 centimeters. Okay, we need to find the distance across the diagonal of the box. Okay, so that's going to be FG. Okay, so let's start. First box, we're going to do the base of the box, and we're going to have a little look for FG. That's the one we want to know. So we've got 12 centimeters and we've got 5 centimeters, and the right angle is in between those, so our FG is actually the hypotenuse. So we're going to square the two short sides and add them together, square root them, and we will get the long side, FG. So we now need to put FG into our diagram. There you go. We've now got our two sides that we need to find the third side. So let's have a look. We're going to be looking for BG now, and we've got our two short sides. So I'm going to use FG to help us find BG. So we've got the two short sides, 13 and 3. They're squared and added together. We then square root it, and we find out that our FG is 13.3. Okay, so whenever you've got a 3D Pythagoras, be prepared to do Pythagoras twice. Okay, so that's that video there.